Before we start factoring, I would like you to realize where the factoring comes from. So say we had the binomials x plus 2 times x plus 3. And you don't really need to write this down. You can just kind of watch this part. If we were to multiply this, we would do x times x to get x squared. X times 3 would give us 3x. Then 2 times x would give us 2x. And 2 times 3 would give us 6. This would simplify to x squared plus 5x plus 6. Think about the 5. What is the relationship between the 5 and the original 2 and 3 in the parentheses? You can talk. It's okay. Last time I said 2 plus 3 is 5. What is the relationship between the 2 and the 3 and the 6? 2 times 3 is 6. So when we factor, we are undoing the process of multiplication. So we're looking for two numbers that multiply to give us this last number 6. Those same two numbers have to add up to the middle number. Those numbers are 2 and 3. And so the factored form is x plus 2 times x plus 3. So let's do that. In example 1a, we are looking for two numbers that multiply to give us 15. Those same numbers have to add up to 8. You're always multiplying to get the last number, the c value, and you're adding to get the middle number, the b value. Some of you are going to look at these and it's just going to pop into your head, and some of you might look at these and think, how the heck did they get those numbers? No matter which side of that you are on, it's okay. If necessary, write down ways that you can multiply to get 15, and then look at those to figure out how you could get 8 from those options. So 3 and 5, 3 plus 5 is 8, 3 times 5 is 15. So the numbers for the parentheses are x plus 3 and x plus 5. And that's your factored form. You can also write it x plus 5 times x plus 3. The order does not matter. The only thing that really matters, you must write the parentheses horizontally. Do not stack them. Okay, B, we are looking for two numbers that multiply to give us positive 12. Now think about it. If we're multiplying to get a positive number, the numbers either both need to be positive or both need to be negative. We are also adding to get negative 7. So if both of them need to be positive or both of them need to be negative, and we're trying to add up to a negative number, that means both of them are going to be negative. So think about ways that you can multiply to get 12. We could get 7 from 3 and 4. We could get negative 7 from negative 3 and negative 4. So x minus 3, x minus 4. Why in the world does it do that? Okay, in C, we are looking for two numbers that multiply to give us negative 6. Those same numbers need to add up to positive 5. If we're multiplying to get a negative, one of them needs to be positive, the other one needs to be negative. Ways to multiply to get 6. We've got 1 times 6 or 2 times 3. A lot of people see the 5 and they instantly think it must be 2 times 3. But 2 plus 3 gives you 5. 2 times 3 does not give you negative 6. It cannot be 2 and 3. How could we use 1 and 6 to get 5? Negative 1 and positive 6. So x minus 1, x plus 6. This class is really concerned about like looking foolish on the video, and I keep trying to tell them that it's totally fine. Wrong answers are good. Struggling is good.
Emily.
It's not.
We're not saying names, Brody.
All right, why don't you try D on your own? What number is in the middle in front of this negative x?
1.
That's a negative 1. So try this one on your own. Anytime that you are trying to add to get a 1 or a negative 1, the numbers need to be really, really close together, like 2 and 3. And if you try 3 minus 2 and you get positive 1, just reverse the order. 2 minus 3 is negative 1. The other hint is, if you're trying to add up to a negative number, the bigger number needs to be negative. If you're trying to add up to a positive number, like in example C, the bigger number needs to be positive. This one factors into x plus 2, x minus 3, or x minus 3 times x plus 2. All right, what is wrong in example 2? There's something wrong with this. This is not in standard form.
Yeah.
You can't factor something that isn't in standard form. You want to rewrite this in standard form. The problem is this is negative x squared minus x plus 20. Every example we've done so far has been positive x squared. You want it to be positive x squared. This negative in front of the x squared is a problem. So here's what I'm going to do. Negative 1 in front of the parentheses, and then I'm going to take the opposite of each term.
There we go.
This is called factoring out a negative 1. If I were to redistribute, negative 1 times x squared is negative x squared, negative 1 times x is negative x, negative 1 times negative 20 is positive 20. But this way, I've created a trinomial in the parentheses that I can factor that doesn't scare me. So we are looking for a pair of numbers that multiplies to give us negative 20. That same pair of numbers is going to add up to positive 1. Anytime you're adding up to a 1, the numbers have to be super close together, like consecutive numbers. So what consecutive numbers, what numbers that are right next to each other can you multiply to get 20? 4 and 5.
I had to think about it for a second.
And if we're trying to get a positive 1, the bigger number needs to be positive, so it must be a negative 4. Negative 4 times 5 is negative 20. Negative 4 plus 5 is positive 1. So the parentheses become x minus 4, x plus 5. Don't forget that negative 1 that we pulled out in the first step.
There we go.
All right. What's wrong with example 3? There's x's and y's. So I want you to focus on the coefficients. We're still thinking about 10 and 11. What numbers multiply to give us 10? Those same numbers have to add up to 11. 1 and 10. So if the y's weren't there, we would have x plus 1 and x plus 10. But this can't be our final answer, because if we multiplied this out, we would not get the y's in there. If you see xy in the middle term, that means that there's a y in the second term of each binomial. So this is x plus 1y and x plus 10y. So now if we distributed it out, we'd do x times x and get x squared. X times 10y would be 10xy. Y times x would be another xy. And then y times 10y would be 10y squared. And those would combine to give you the 11xy. You don't need to do that step. I'm just showing you that that's why those y's have to be in there. So when you see an xy in the middle, that just means that in your factored form, there's going to be x's here and there's going to be y's at the end of the binomials, and then whatever numbers you come up with, just go in front of the y's. So here we're looking for two numbers that multiply to give us negative 12 and add up to what numbers in the middle? Negative 1. Anyone know what those numbers are? 1 times 12, 2 times 6, 3 times 4.
There we go.
3 and negative 4. So that means there's a plus 3y and a minus 4y. You just have to stick that y in the second part of the binomial, and then you're good. This says completely factor. Anytime you see the phrase completely factor or factor completely, it's math's sneaky way of saying, hey, this is a problem that's going to take more than one step. You're going to have to factor and then factor again. We really want our first term to be plain ordinary x squared. So this is combining yesterday, which is section 6.1, with today, which is section 6.2. What do these three terms have in common? The first thing we need to do is think about a greatest common factor. Do these two terms have anything in common? Or these three terms? It'd be really nice if we could divide all of them by 3. Can we divide all of those by 3? Yes. Yeah. And how many x's could we pull out of all three terms? Just an x. 3x to the third divided by 3x would be x squared. Negative 27x squared divided by 3x would be negative 9x. And 54 divided by 3x would be positive 18. Take a moment on your own, pause the video, factor the x squared minus 9x plus 18. So inside the parentheses, we will have x minus 6, x minus 3. Don't forget we've got a 3x out in front. So part 1 is factor the GCF. Part 2 is figure out how to factor the trinomial that's left over inside the parentheses. And for a final example, this is straight from an ACT test. And they basically want you to think about how factoring works. If we were going to factor this, we would be looking for two numbers that multiply to get us 16. Those same numbers would add up to whatever b was. And they're asking us, what numbers could b be? So think about ways to get 16. We can do 1 times 16. I can't write worth a crap. We can do 2 times 8. And we can do 4 times 4. If we put 1 times 16 in here, what is 1 plus 16? 17. So b could be 17. If we put 2 and 8 in the blanks, what's 2 plus 8? Not all at once now. 10. If we put 4 and 4 in the blanks, what is 4 plus 4? 8. Now, if you're trying to get a positive 16, these could also both be negative. So b could also be negative 17, b could be negative 10, and b could be negative 8. This is just, if the ACT did this, it'd be a way of them to look at how well do you understand the things that go into factoring and how the b and the 16 are related to each other. And here's your assignment.